Hello everyone, I'm Sudhanshu Mukherjee and my topic is command line tool for exploration and visualization of data. So my advisor was Dr. Alfa. So the problem statement I was working on was developing and building an efficient user-friendly tool which is capable of performing pre-processing tasks directly on the terminal. So you don't have to go through any sorts of code and uh, other jitters which we go through. So you can directly perform your data pre-processing tasks on any data set right through the terminal. The solution to that problem statement was PrepUp. So PrepUp stands for Pre-Processing Utility Package. Uh, it is a free open source tool which lets you inspect, explore, visualize, impute, and standardize the data set right from the terminal. PrepUp supports three file formats as of now, CSV, Excel, and Parquet. You can install PepUp using the pip package manager. It has already been uploaded in the PyPy directory. So you can install it directly on the terminal. It is compatible with two operating systems right now, which is Windows and macOS. For the Linux part, I'm facing some issues which will be get resolved in the later versions. So why use PrepUp? So first thing, it's fast. It doesn't use traditional pandas data frame in the backend to load the data set. It uses Polars. So Polars is the library built on Rust, which is an alternative to pandas, and it lets you load the data and manipulate data just like pandas. And it's analytical. Uh, and it lets you perform all sorts of pre-processing from imputing missing values, checking the skewness, kurtosis of the data set right from the terminal with minimal code and just using command line arguments. It's compatible. It supports three file formats, like I said, and it's non-destructible because it doesn't change your raw data unless you explicitly ask it to. So you can directly save the files you are working on into a new data set. It doesn't alter your raw data. It's completely terminal based. So it lives on your computer. You don't have to worry about any different tools. You can directly pre-process data sets and use those data sets to directly build a model on it. And it's keyboard driven if you don't like using mouse. The flags. So these are prepper flags. PrepUp is designed in such a way that when you run it through terminal, you don't have to import this package like other packages which you work on. So usually when we work around the packages on the terminal, we need to call Python and then work our way around it. But PrepUp is designed in such a way it directly gets you to the entry points with the keyword PrepUp. And we have these flags available, which I'll be discussing in. So first we have inspect flag. To use an inspect flag, what you can do is call prep keyword. Then you pass the file. If it's in your current directory, you can directly specify the file name. And or if it's in a different location, you can pass the path and then use the inspect flag, which will give you the dataset features names, the type of dataset, shape of data, missing value count. Then there's explore flag. Explore flags gives you data set name and data set feature just like inspect. But other than that, it gives you the correlation between the features available in your data set. So there's like a magic function working in the background, which actually iterates over two loops working on the same columns and compares the correlation values between those features and displays it directly on your computer. Then we have outlier detection method, which detects outlier. Outliers are detected using the Tucky method, where the threshold value is currently set as 1.5. But in the future version, we can ask the user what threshold value they want to use. And then also, we also have a feature where it tells you which feature in your data sets are normally distributed and which are not. So the features which are not normally distributed are represented in the red color, and the feature which are normally distributed are in green color. Then it measures the skewness of the features present in the data set. But the current problem with the skewness is it returns nan for the columns which have missing values. In the future version, I'm trying to build a function where it directly gets the normalized data set after all of your pre-processing and then calculates the skewness values of it. And same goes with kurtosis. And then sometimes we are also working with the classification data set where we want to check if our data set is imbalanced or not. So this feature allows you to check if your feature is imbalanced or not just by passing the feature name. Then we have the visualize flag. Visualize flags shows you the distribution of the feature right on your terminal. And then we have impute flag, which helps you impute missing values in the data set based on 8 different strategies, which we regularly use. The two strategies which I have added is fifth one, which is distribution based on the each feature, where we calculate the mean of that feature and standard variance and take random numbers between that range and impute missing values with it. Then we have the eighth strategy, which is it imputes missing values with the nearest neighbor of that particular value, and the closest one get imputed in that data set. Then we have standardized function where we have an option to use robust scaler and standard scaler. And robust scaler can be used if you're worried that outliers can influence the model. And we also have standard scaler, which has a mean of 0 and a standard deviation of 1 when we use standard scaler method. And for the benchmark performance of my tool, I have used the Higgs dataset comparable to other 4 datasets. So for the Higgs dataset, it's close to it has around 11 million rows with 29 features. And you can see the values. For the inspect value, it only took 2 seconds. And for the explore, it took 273 seconds. And it had no missing values. But for the visualization of that Higgs dataset, it took around 1500 seconds. And standardized was also completed in around 28 seconds. So all in all, in around 1751 seconds, the whole pre-processing part was done on Higgs dataset, which is around 2.8 GB of data. And this is the visualization of each different flag compared to other 5 datasets which we saw in the previous slide. And the total runtime is calculation of all the flags. And this is the plot which tells you the difference between Pola's data frame and Panda's data frame. If you can observe, Higgs dataset takes less than 12 seconds to load in using Pola's, whereas using Pandas, it takes more than 40 seconds. Now, I'll be demoing my tool. So I'm just using random data to demo this tool. So all I need to do is use prepup keyword, pass the file path, and use inspect function. As soon as I do it, tool gets loaded. It gives you features, missing value counts, everything. Now I'll be using the explore flag. It tells you about features. So it tells you about the feature correlation between each feature compared, just like the correlation matrix which we use in Jupyter Notebook. It gives out the value. Then this is the normal distribution, check for the normal distribution in the data set. Then we have outlier detection. Then we have skewness present, and we can also check for imbalanced data. So this is the visualize function, which visualizes the distribution of each feature. And at the same time, that these values don't make sense, it also normalizes the value so that it can plot directly on the terminal. Now I'm using impute flag where I'll be just passing on the value, which is impute missing data with this specific value. So I can just pass any value. I'll be passing 100. And this is the path where this missing file will be saved, where it will directly save. So you can see it directly saves the file, and it does the same thing for the standardized function. So for the standardized function, what it does is first checks the current directory of the tool. Like if there is a missing data Parquet file present. If there's a missing data Parquet file, it directly loads that file and then standardizes it. So I'll be using robustscaler. And so this was the folder location. You can see missing data imputed and normalized data, which is just saved right now. And that's all from me. Thank you. Yes, you can directly install it using pip manager, pip install prepper. It loads the latest version for the tool. I think we need to work around Google Pages more. So this is the repository where you can use the tool, open issues, and if you want to add something, just go ahead and do it, because I am planning on maintaining this, and I need to learn more about how to build a software package and use it and maintain it for a longer time. So you're welcome to contribute in this. Yes. Yes. It's compatible with Conda. So the first thing which I did was I tested it in the Conda virtual environment, and it works great on the Conda. It has some issues. I was facing some issues while installing it in the normal command prompt available in the Windows. But usually, if you're using command prompt as an administrator and installing it, it does all the job. And after that, you can use it as a user. But while installing, it's best suggested to use a virtual environment or installing it as a administrator. No, so right now it's not compatible with the categorical data. It only takes in account as numerical data. So for every value which we saw, what it does is it filters out the data which is not numerical, and then it performs operations on it. So it's for all the pre-processing tasks which we saw, it was all done in Polars. But in the future versions, we'll be using Dask instead of Polars, because it's much more faster than Polars. So the initial idea and the instructions for using the tool will be same, but in the backend we'll be using Dask, so that it becomes more faster and highly scalable for the large data sets.